Okay, so next up is ultrasonic sensor. In this section, we will learn about what is an ultrasonic sensor, how it works, and how we can use it for our robot. Before we look at how it works, let's talk about what is an ultrasonic sensor. An ultrasonic sensor is a device that can be used to measure distance by using sound waves. So within the sensor, there are two main components. One of them is the transmitter, and the another one is the receiver. What the transmitter does is sends out a high frequency sound wave, which will get reflected back from the object, and the receiver end will receive that signal. So with these two things, we can calculate the distance by taking the time multiplied by the speed of sound divided by 2. The time is the amount of time where the transmitter sends the pulse plus the time it takes for the sound wave to reach back to the receiver after getting reflected by the object itself. Hence, we divide it by 2 so that we only get the time where the transmitter sends the wave all the way to hitting the object. So next thing is the code. We will look at how we can set it up. So again, like I said, there are two main components. We have the trigger and echo, which is the transmitter and the receiver. So you want to define two pins for them. So in this case, you can see for trig, we have 4, and for echo, we have 3. And we initialize two variables. One of them is to calculate the time, and the other one is to calculate the distance. And both of them are float because we want decimal values, not a integer, for example, which are whole numbers. And in the setup, we need to set up the pin mode. So for example, your trig, which is the transmitter, which is an output because you're sending the wave. And the second one is the echo pin, which is an input, which is the receiver. And then you also want to get the serial baud rate to set to 9600 so that you can print out the distance to the serial monitor. Next thing is wiring. This is done on Arduino Uno, but it should be similar to Nano. But in this case, you can see our VCC is connected to 5 volts and ground is connected to the common ground. But our trig is connected to number 4 and our echo is connected to number 3. In this case, the pin assignment doesn't matter as long as you connect them to any of the digital pins, for example, 5, 6, or like 8, 9. Next up is we will look at how we can actually use this in our main loop to get the distance itself. So before, we already looked at how we assign the pins. Now we want to actually send the trigger. So in this case, the first thing we got to do is we want to clear the pin, the transmitter, and then we want to send out a high trigger. So in this case, we're sending out a high frequency sound wave, and we want to wait for a bit and then we want to shut the transmitter low. So low means we're shutting it down, and then we wait until the receiver end receives the high receiver end receives the sound wave back. So in this case, that will be our total time. So we want to take that time, multiply it by the speed of sound, divided by 2 in order to calculate our distance. Like I mentioned earlier, we can also use a serial.print line to print out the distance so that you can use this either for just to verify that your sensor is working properly, or if you can use this for troubleshooting purposes. And in our SumoBot, there's many different ways that you can use this, but one of the main simple ways is basically you can figure out the distance of another SumoBot in front of you. So for example, if the distance is greater than 2 but less than 15, so that means they're at least 15 centimeters away from us. In this case, we can keep moving forward. Otherwise, if we're near them, then we can do something else.